Welcome once again to this online session where we are trying to discuss present worth analysis as a part of the subject of economics for engineers. In our discussion till now, let me share the presentation with you. In our discussion till now, we discussed different techniques for economic analysis, which primarily includes present worth analysis, annual cash flow analysis, and rate of return analysis. Because we are interested here in studying present worth analysis, we have understood what present worth analysis is and what are criteria and context with present worth analysis related to or for economic efficiency. Again, through different illustrations, we have tried to calculate what present worth or present value of different alternatives is, and we have also discussed some of the interesting and useful relations in calculating the future sum, the annual cash flow, as well as the present worth. We will be using those relations in today's presentation when we would start discussing the examples. But before we actually move on to the examples, let us try to discuss some of the common assumptions which are done while doing economic analysis of any engineering problem. So, whether it is rate of return analysis, whether it is annual cash flow analysis, or whether it is present worth analysis, generally these assumptions remains the same. These assumptions are taken so as to simplify the complexity of the problem, right? We understand that the nature of economic analysis problem can be quite complex, but when we take such assumptions, it helps us to simplify this complexity, and we consider this to be appropriate till the time the solutions that we obtain after taking this assumption is satisfactory and quite close to the real solution. Following are few methods where conventionally the assumptions are made in economic analysis. These are end of year convention, viewpoint of economic analysis studies, sunk cost, borrowed money viewpoint, effect of inflation and deflation, and last is the income tax. Let us try to understand in regards to each of this what are the assumptions that we make. Let us try to discuss each of them one by one. Starting with the end of year convention. What do I mean by this is that in the study of cash flow, in economic analysis, cash flow is always a part of the analysis, part of the study. And in cash flow, we primarily deal with three elements, which is the present value or the present sum of money, P, the future value or the future sum of money, F, and annual disbursements or receipts, which we generally call it as end of period cash receipts or disbursements, which we popularly or commonly represent by letter A. Thus, what does end of year convention basically mean? Considering end of year convention, our cash flow diagram would appear something like this. That is, I would have some present value or future sum of money. My annual cash flow would primarily be at the end of the year. So my year starts at January 1, my year ends at 31st December. My next year starts from January 1 again. So my annual disbursement would be at the 1st January, or I would say 31st of December. So here what we understand is that when we are talking about end of period receipts or disbursements, we generally take it as end of the year, right? There can also be, to understand this more clearly, we can also have another concept which is middle of period convention, right? Which is middle of period convention. Now, if I'm using middle of period convention, then my cash flow diagram would look something like this. I may start with year 0 here, say 1st January. My middle of year convention would would allow me to have my annual cash flow in the middle of the year. That is, say, for example, June 30th. Similarly, in the second year, again June 30th. Whereas my present instance is considered as January 1, and my final or future sum value, that is end of analysis period, is considered as 31st December. So here we have middle of period convention. Now, what is the assumption regarding economic analysis in terms of such convention? The assumption is that in economic analysis, we would stick with the uniform assumption of end of year rather than middle of the period. It means that we would stick with this nature of cash flow rather than this nature of cash flow, right? So we would use the assumption of end of period rather than the middle of period convention. So this is the first assumption in terms of end of year. The second is the viewpoint of economic analysis studies. By viewpoint, we are trying to indicate that what are the factors that I need to consider while I am doing economic analysis, right? Economic analysis is, after all, comparing different alternatives. And while comparing these alternatives, it is necessary that we evaluate these alternatives on some criteria which is not only common for all alternatives, but it should also be neutral. It means that my criteria should not be such that it should have biasing for some alternatives and negative biasing for some others. So the criteria that I use for evaluation should be neutral and common to all, right? Further, it is necessary that the viewpoint of setting this criteria should be comprehensive. It means that we should not use a narrow point of view in setting this criteria. We should consider each and every aspect which this criteria or the analysis problem relates to while setting the evaluation criteria. Let us try to understand this by means of an example. Let us say, for example, in economic analysis of a large organization which is consisting of number of departments, the analysis should not be done for each department in isolation. That is, when we have a large organization which consists of number of departments, there would certainly be some interdependencies between the departments. So when I am analyzing, I should not analyze each department as an isolated unit. Instead, I should assume, or I should take a broader perspective, a broader viewpoint, and I should adopt in criteria considering the interdependencies between the department, the HR needs and the obligations for a department, the social responsibilities towards any particular department, etc. Again, if our economic analysis problem is related to public sector units, say for example any government undertaken projects, right? Then the combined viewpoint of all stakeholders like government, general citizens, social organizations, etc., should be considered while setting up the evaluation criteria. This is because in projects like this, say for example constructing a new highway or constructing a railway link, it is the government which is going to invest, but the benefits are going to be received by individuals or society. So a broader view, that is the viewpoint of all stakeholders, should be taken in setting up the evaluation criteria for such problems. Thus, the important part is that a comprehensive viewpoint has to be taken covering social, economic, as well as ecological benefits, and we should take into consideration all the stakeholders related to or which are going to get affected by the problem at hand, right? So the common assumptions in setting up the economic criteria is that the viewpoint of economic analysis should be comprehensive, should be inclusive of all the spheres that it basically touches upon. This certainly increase little level of complexity, but the narrow viewpoint approach would not give us the correct results. Let us go to the third point, uh, related to which general assumptions are taken. This is the sunk cost. We all know that sunk cost is the cost that has already been spent, that has already been incurred and cannot be recovered now, right? If the cost which we have already spent is not relevant to or does not affect the present project, right, then it should not be considered in the economic analysis. The point is that the past cost that do not affect the present or future of the current project should be disregarded. It should not be considered. So, in any economic analysis problem that we would take at hand, we would assume that my sunk cost is zero. It means that I would not be considering sunk cost as a part of my analysis. The next point of assumption is borrowed money viewpoint. Now we had to understand that in economic analysis, all alternatives are inevitably related with spending of money or related with the cash flow. That is, money is the major part of this analysis. Now, this monetary aspect can primarily be divided in two parts. One we understand as financing, and another we call it in investing. What is financing? Financing is basically the problem of obtaining the money necessary to use for the project. And what is investing? The investing is the problem of how I would spend this money. So, in an economic analysis problem or any engineering problem, the the issues related to monetary aspects would be related to financing and investing, and one has to clearly understand between these two. That is, what is the part of financing and what is the part of investing. Again, uh, when I'm talking about project finance, that is obtaining money for the project, I can have popularly two alternatives. One is I would borrow the money from others. This others may include banks or any financial institutions or any individual. That is, I would get the money by borrowing the money from some agency. And the second part is that I would invest my own capital in the project. When I say that I invest my own capital for the project, I mean that company might have some reserve fund which it may invest, or or something that we call equity fund. The company might have number of shareholders whose money would be invested in the project rather than borrowing it from some institution. Now, in economic analysis problem, whether the source of finance is the borrowed capital or one's own capital, we always consider that the money which goes in economic analysis is used, the money which goes in economic analysis as a finance is obtained at some fixed interest rate. So it does not matter that what is the source of the money, we would always consider that the money which is actually used as a finance for an economic problem is always at some fixed interest rate. Certainly, if the money is borrowed from bank, we understand that it would always have some interest rate. But other ways also, whatever be the source of money, we would always consider that the finance is obtained at some fixed interest rate. This is what we call it as borrowed money viewpoint. The next point is the effect of inflation and deflation. We understand that inflation or deflation are certainly one of the major factors that affects the economic aspect of any project. However, in economic analysis, generally the price over the period of the project is assumed to be stable. That is, we assume that there is no effect of inflation or deflation, right? The effect of inflation and deflation are not considered in economic analysis. The cost of the machine, what I mean by this is the cost of the machine today and that after several years during the project period is assumed to be same, right? Why we do this is because the effect of inflation and deflation are generally considered after tax analysis, because related to inflation and deflation, tax the tax structure given by any government changes. So, in the initial phase of economic analysis, till the time we don't reach to the text phase of it, that is when we are doing before text analysis, we generally don't consider inflation and deflation. Inflation and deflation are certainly considered as a part of economic analysis, but they are considered in after text analysis and not before text analysis. What primarily we are doing in this subject is before tax analysis, and hence we would not be considering the effect of inflation and deflation. Lastly comes is the income tax. Like inflation and deflation, income tax is also an issue which is related with after tax analysis. So in our discussions, so far as present worth analysis or any economic analysis problem is concerned, we would not consider income tax as a part of it. Again, as I said, it certainly plays an important role, but it is better to discuss about this in after tax analysis rather than before tax analysis. So we make, these are the common assumptions, six different common assumptions made on six different areas which would remain same in any economic analysis problem, whether we try to solve it using present worth, or we try to solve it using annual cash flow, or we try to solve it using a rate of return analysis. Fine. Now, having discussed this, let us try to move on to different examples on present worth analysis. Now, the examples of present worth analysis can be better understood if we classify them with respect to the period over which we need to do the analysis. That is, let us try to take case 1. We take case 1 as the useful life of each alternative is equal to same as the analysis period. That is, for a problem, I may have more than one alternative, and we consider that useful life of each alternative is equal. That is, I may have option 1 and option 2. The useful life of option 1 and option 2 would be same, and that would be same as the analysis period. This would be the most simplest case to handle. Case 2 is that the alternatives have different useful lives from the analysis period and also from each other. What do I mean by this? Is that I am supposed to make a choice between, I'm giving an example, that I'm supposed to make a choice between machine A and machine B. Now, the useful life of machine A is maybe 4 years, the useful life of machine B is 6 years, and my analysis period is 8 years. So here, the useful lives are different from one another for each alternative, as well as they are different from the analysis period. So this is our case 2. This is relatively difficult to, or I would say complex to handle compared to case 1. And what is the third case? The third case is my analysis period is effectively infinite. Say, for example, a government is constructing a bridge, or a government is constructing a dam. What we would consider as the useful life of a dam? Effectively infinite, right? So we would also have to undertake present worth analysis for engineering problems like this, where my analysis problem is effectively infinite. We will try to take examples on each case, trying to understand what can be our approach. Let us try to take the example of case 1, where we have same length analysis period. That is, useful life of each alternative is same, and it is same as the analysis period. Let me propose a problem statement to you. Let us understand this quite well. When we are discussing examples, it is my request that when we are discussing the example, always have your calculators and all necessary stuff with you. It would be better if you solve the examples in parallel to what we are discussing, so that you would get a kind of confidence and you would get the clarity about what is happening. Fine. Coming back to the problem statement says that the company plans to purchase machine available from two different brands, say A and B. Both the brands provide equivalent service and 5-year service life of a machine. Detail of both machines are as follows. Brand A machine has an initial cost of 40,000 with annual operation and maintenance cost of rupees 30,000 and a salvage value of 5,000 after its 5 years of life. On the other hand, brand B has an initial cost of 60,000 with an annual operation and maintenance cost of rupees 20,000 with a salvage value of 12,000 after 5 years. If we assume that the assured interest rate is 15%, and we are asked to decide that which machine one should purchase using PW analysis method, that is present worth analysis method. I would request you to pause at this point, go through the statement of the problem once again, try to list down the details, what the problem is indicating, and then again restart with the video. Fine. I hope you would have understood what the problem is. Let us try to move on towards its solution. Right? Because the machine from both the brands have equivalent service. This is talking about both of them have same benefits. The approach of present worth analysis criteria would be to minimize the present worth cost. Remember that in present worth analysis, we always try to maximize the net present worth. And what is the net present worth? The net present worth is present worth of benefit minus present worth of cost. Now here, the present worth of benefits, because both the brands offer the same benefits, because they are equivalent in service, both of them offers same benefits. Our benefits are fixed. So to maximize net present worth, I would have to minimize the present worth cost. So we would be opting for an option which has minimum present worth of cost. Right? Let us try to summarize what has been given as a data to us. We have two brands, brand A and brand B. The machine from brand A cost 40,000 initially and brand B cost 60,000. The annual cost in terms of operation and maintenance is 30,000 in case of machine from brand A and 20,000 in case of machine from brand B. The salvage value after 5 years of life span is 5,000 and 12,000 in case of machine A and machine B respectively. And useful life of both is same. Certainly it would be, because we are talking about examples which are same length analysis period examples. It means that the useful life of all alternatives would be same, and my analysis period would also be same as its useful life. The other detail that is given to us is about the interest rate which we are supposed to calculate, which we are supposed to consider to be 15%. So considering this data, let us try to find what would be the present worth of cost, because we are supposed to minimize this. What is the present worth of cost for brand A and brand B? What are the factors which would be part of present worth of cost? Let us try to take one by one. The first is the purchase cost itself, which is nothing but the present value. For brand A, it is 40,000. What would be the second part? The second part would be the present worth of annual cost for 5 years. So I have an annual cash flow of 30,000 every year for next 5 years if I'm using brand A machine. So if I try to calculate what is the present worth of this annual cash flow of 30,000, then you should remember that we have this relation with us, the relation which relates annual cash flow with its present worth of cost, right? So my annual cash flow is 30,000, my interest rate is 15%, and my number of years are 5. So if I put this in relation, then I would get it an amount somewhere equal to 1,564.65, right? So this is the present worth of my annual cost. Now what remains is my salvage value. So what would be the present worth of salvage value? Now understand that salvage value is something that you are going to get only at the end of the service life, when you are going to salvage the machine. That is when you are going to throw away the machine or sell the machine, right? Or scrap the machine. So this is the money that you would get at the end of 5 years. So the how what would be the present worth of this 5,000 which I am going to get after 5 years? For this, we may use the relation of compound interest. That is, the present value of the future sum would basically be P equal to F1 plus I raised to power minus N. So according to this, if I try to calculate, I would get this figure. So now the present investment is 40,000. The present cost of annual cash flow for next 5 years is this, and this is something which I am going to get back at the end of 5 years. So understand that this 40,000 is what I am spending, this amount is what I am spending, and this is what I am going to get back. So if I put it in terms of cost, then I would take this as positive, I would take this as positive, and I would take this as negative. I'm considering cost. So I'm looking at my investment. So this is what I invest, this is what I invest, and this is what I get. So my net investment, my net present worth of cost would be somewhere close to 1,38,078 rupees. Right? Now let us try to calculate the same thing for brand B. So for brand B, my purchase value is 60,000. My present worth of annual cost for next 5 years, I would use the same relation, but instead of 30,000, I have 20,000. So this would result into some amount close to 67,000. And if I try to calculate the present worth of salvage value, I use again the same relation as what I did here. But here I had 5,000 of salvage value. Here I have 12,000 of salvage value. So this is the amount that I would get. So if I add this two and subtract this from it, what I would result in would be this amount. Now what is our goal? Our goal is to minimize the present cost, minimize the present investment, right? That is, minimize the present worth of cost. So we understand that compared to brand A, brand B proposes less present worth of cost, and hence brand B would be something which would be a better alternative compared to brand A. You can take a pause here. You can go through this calculation. I would request you to do it by your own once. It would give you the clarity of idea what we are doing and what is the flow of calculation. You can take a pause here. Fine. I am sure you would have got a good insight into this. Now let us try to go to case 2, where I have a different length analysis problem. Right? In this, we would consider two cases. Case 1, where uh, the alternatives that we are considering have unequal lives, and there is no fixed horizon for analysis period. It means that analysis period is not given to us. Analysis period is not given to us, but the alternatives has unequal life. That is, say for example, that I may use machine X which has 3 years of life, I may use machine Y which has 4 years of life, and the analysis period is not mentioned. When the analysis period is not mentioned, the easy approach is to take analysis period equal to the least common multiple of two alternatives. That is, the analysis period of X machine is 3, the analysis period of Y machine is 4. Sorry, the service life or the useful life of machine X is 3 years, the useful life of machine Y is 4 years. Analysis period is not mentioned, so I would take analysis period equal to LCM of 3 and 4, which is equal to 12. So what would happen in this is that during the analysis period of 12 years, we would have to replace, say, machine X at the end of its service life. That is, I would have to replace machine X after 3 years, 6 years, and 9 years, whereas I would have to replace machine Y after 4 years and 8 years, right? So this is something which has to be done. What is case 2 of this? Case B, I would say, that the alternatives do have unequal lives and there is fixed horizon for analysis period is mentioned, right? Then if the fixed horizon of analysis period is mentioned, then I cannot take analysis period to be LCM of two useful lives as we have taken in case A, right? Say for example, if I have machine X which has 3 years, I have machine Y which has 4 years, and my project life is expected to be 6 years, then certainly I cannot take my analysis period to be 12 years because I am strictly given that my period of project is 6 years. In cases like this, we certainly need some little more information regarding the salvage cost of machine at different stages of its useful life, right? We would take example on each case and we would try to understand what are the intricacies or the issues involved in each. Let us try to take the example of case 1. This is the problem statement that we have. A company, I am trying to keep the problem structure to be similar so that we don't get stuck into the problem structure. Once it is understood, uh, let it not spend more time in that. Let us try to understand the procedure more. So again, a company plans to purchase machine available from two different brands, say A and B. Both brands provide equivalent service and machine have same annual O&M cost. Details of both the machines are given as follows. Brand A has an initial cost of 25,000. It has zero salvage value and 3 years of service life. Whereas brand B has an initial cost of 30,000, zero salvage value and 4 years of service life, right? Assuming minimum attractive rate of return to be 15%, we are supposed to decide using present worth analysis which machine should be purchased. If you carefully see this problem statement, you would realize that the alternatives that we have has different useful life, has a different service life. Brand A machine has 3 years, brand B machine has 4 years. And actually, I am not given with what is the project life. That is, what is the analysis period that I am supposed to take, right? If required, you can take a pause here and you can go through the problem statement once again to clearly understand what the problem is mentioned. Fine. If we go ahead, then let us try to identify a few things. Here again, the machines are said to have equivalent service. So our benefits are same. So the appropriate PW analysis criteria would be again to minimize the present worth of cost. Again, it is said that annual O&M, that is operation and maintenance cost, is same, and hence, if it is not considered in economic analysis, it is okay. We even are not given what is the value of annual O&M. So, because they are same in both the cases, it is not necessary for us to consider. Again, both the machines are said to have zero salvage value. It means that we would also be not, this would also not become the part of our analysis because the salvage value is zero. Now, because both of the machine have a different service life, I would try to select an analysis period which would be equal to LCM of the two service life, that is LCM of 3 and 4, which is 12 years, right? So to summarize, the details given in the problem, then we have machine from brand A and brand B. Machine from brand A costs 25,000, whereas this costs 30,000. The useful life for machine A is 3 years, for machine B is 4 years. The analysis period which we have taken is of 12 years, which is LCM of 3 and 4, because there is no fixed analysis period given as a part of example, right? So because 12 years is a longer period compared to the service life, I would need replacements. So in machine A, I would need replacement at the end of year 3, end of year 6, and end of year 9. EOY stands for end of year. Whereas machine from brand B would require replacements at end of year 4 and end of year 8. Other data that is given to me is the interest rate, which is 15%. So from this data, we are supposed to identify what is a better alternative, whether to go for machine from brand A or machine from brand B. Let us try to calculate the present worth of cost for each of them. Let us start with the present purchase price. In any case, if I purchase brand A machine, I am supposed to pay 25,000. Then what would be the present worth of purchase of cost after n years? Because I have to replace the machine 3 times, at the end of year 3, at the end of year 6, at the end of year 9. So again, we have discussed in our assumptions that we don't take into account inflation or deflation. That is the value of the machine. We would consider it same throughout the period of analysis. So the machine that I would purchase at the end of 3 years would also cost 25,000. The machine that I would purchase at the end of 6 years would also cost 25,000. In same way after 9 years. So after 3 years, I am supposed to spend 25,000. After 6 years, again I am supposed to spend 25,000. Same way after 9 years, 25,000 for granting. So I have to calculate present worth of each of these purchases. And for this, because this purchase is done once at 3 years, 6 years, and 9 years period, I would I would take this in terms of a future value rather than annual cash flow. It is not an annual cash flow. So I would use this relation. Here my N would be 3, 6, and 9, and my interest rate I is 15%. So the first replacement after 3 years would be 25,000, 1 upon 1.15 raised to power 3, which costs somewhere around, whose present worth is somewhere around this. This is after 6, and this is after 9 years. Right? So if I try to calculate the present worth of cost, then 25,000 is my present investment after 3 years. The present worth of it is 16,000. Investment after 6 years, the present worth is close to 10,000. And investment after 9 years, its present worth is somewhere around 7,000. So my total cost would be this much amount, 59,352.65. Let us try to do it for the brand B. In brand B, the current purchase cost is 30,000. The present worth of future cost, that is future purchase after n years, I would use the same relation. But here I would have to use this relation 2 times, that is at the end of year 4 and at the end of year 8. Again, I would not consider inflation and deflation, so my value of machine would be same after 4 years and 8 years, and this would render me this value. So now if I try to calculate the present worth of cost, then it is the present purchase cost of 30,000, purchase cost after 4 years, whose present worth is 17,000, purchase cost after 8 years, whose present worth is 9,800. So my total would be somewhere close to 56,959.64. As we are looking for the minimum present worth of cost, this is minimum present worth of cost. So out of brand A and brand B, my selection would go to brand B. Again, I would request you to take a pause here, go back to the example, again try to go through the calculations that we have done. It is necessary that you understand it well. Once you do it by your own, you will get the clarity of idea and the sequence of things. Right? The other examples of present worth analysis, so far as different length analysis period is concerned, that is different length analysis period for case B is concerned, and more examples on present worth analysis we will try to take up in the next session. Thank you for joining. Thank you.